Good evening, students. We'll consider this signal flow graph to find the transfer function by using Mason's gain formula, which is starting from this node and ending at this node. Okay, and here these two nodes are considered as dummy nodes because these two are the extra nodes with a gain of 1. Okay, so the Mason's gain formula is transfer function is equal to algebraic sum of tk delta k divided by delta. Okay, first to find the transfer function we should find the number of forward paths. So first we'll check the forward paths here. The forward path is the one we should start from the source node and we should end at the destination node. Okay, first forward path is g1 g2 g3 g4. Okay, this can also be written as 1 starting from this dummy node only, 1 g1 g2 g3 g4 into 1. Okay, that is nothing but g1 g2 g3 g4 g. Okay, so check for another forward paths again. The second possibility of having forward path is g1, which is moving in the same direction, g5, right, which is starting from source node and ending at the source node itself, g1 into g5. Considering dummy node also we can write 1 into g1 g5, that is equals to again g1 g5. We'll get two forward paths here. Check for any other possibilities. We'll not get any more forward paths here. Okay, if you got two forward paths, this transfer function can also be written as, right, by using this main formula. If we have only two forward paths, this can be written as t1, right, delta 1 plus t2 delta 2 divided by delta. Okay, if the number of forward paths are 3, in that case it will be t1 delta 1 plus t2 delta 2 plus t3 delta 3 divided by delta. If 4, t1 delta 1 plus t2 delta 2 plus t3 delta 3 plus t4 delta 4 divided by 4. That means this formula is dependent on the number of forward paths. Here we are having only two forward paths. That's why this formula can be written as t1 delta 1 plus t2 delta 2 divided by delta. So after finding the number of forward paths, we should find the number of loops. Okay, we should very carefully observe the four number of loops. Here g1 g2 with this s3, which is forming one loop. Okay, that one I will consider as first loop. L1 is equals to g1 g2 into minus s3, can be written as minus g1 g2 s3. Okay, so for second, again similarly this is forming one more loop, g2 g3 into s minus h2. So second loop is minus g2 g3 s2. Okay, third loop again g4 into minus h1. Third loop is g4 into minus h1. Then fourth loop is this g5, which is moving in this direction, and this way is moving, it is in reverse direction. The fourth loop can be considered as g5 into minus h1 into minus s2. Okay, that can be written as g5 h1 s2 because minus h1 into minus s2 is plus, minus into minus is plus, therefore I have written g5 h1 s2. Okay, check for any other number of loops. We will not get any number of loops here. We should very carefully check for the number of loops. Here how many loops we got? We got number of loops we got here are 4. After finding the number of loops, okay, if number of forward paths are 2, we'll get two deltas, delta 1 and delta 2. We should find the number of delta 1 deltas. Okay, so first we'll find delta 1. Delta 1 is equals to 1 minus any loop which is not touching to the first forward path. Delta 1 is equals to 1 minus any loop which is not touching to the first forward path. Check for any loop which is not touching to the first forward path. See, all the loops are touching to the first forward path because first forward path is g1 g2 g3 g4. Okay, g1 g2 is common here, that means it is touching, this is also touching, this is also touching, this is also touching. That means we are not getting any loop which is not touching to the first loop. That's why I will consider 0. 1 minus 0 is equals to 1. Similarly, delta 2 is equals to 1 minus, you should consider the loop which is not touching to the second forward path, which is not touching to the second forward path. Second forward path is g1 g5. See, first g1 is common here in the first loop, that means it is also touching. Here, though there is no common gain in between second forward path and second loop, here you just go through the signal flow graph. G1 gain is involving two nodes, this node as well as this node, and the second loop G2 is involving this node and this node. That means this is the common node for second forward path and second loop. That means it is also touching. Okay, similarly G4 gain is involving these two nodes, and the third loop, okay, G4 is involving these two nodes, and the second forward path G5 is involving this node and this node. That means this node is common with this third loop. That means it is also touching. Similarly, the fourth loop is also touching. That means we are not getting any loop which is not touching to the second forward path. That means I'll consider 0 again here. Delta 2 is equals to again 1 minus 0. Okay, after finding T1, delta 1, T2, delta 2, we should find the delta. Delta is equals to 1 minus summation of all the loops. How many loops we have? We have 4 loops. L1, L2, L3, L4. Right? Here we have considered minus. The next term will be plus. Then check for the pair of two non-touching loops. Okay? Here L1 and L3, right, these two loops are non-touching to each other. L1 and L3 are non-touching to the non-touching loops here, L1 and L3. L1 and this loop L3 are the two non-touching loops, because here the no gain is common, and if you go through the signal flow graph, okay, then also any common node you will not get here. So after finding pair of two non-touching loops, again if you go through carefully through the signal flow graph, you will not get any pair. After this, if in any problem, if you are getting a pair of three non-touching loops, then again you can write here. Here you have considered plus, next you have considered minus, then write for the three non-touching loops. Okay. So as far as this problem is concerned, we'll get only up to two non-touching loops. Okay. So then by substituting the value of L1 and L2, you just simplify the value of delta. Okay, 1 minus L1 can be written as this one, minus of G1, okay, minus G1 G2 S3, then plus L2 is in the bracket, again minus, plus in the bracket minus G2 G3 S2, then plus L3 plus L3 in the L3 is minus G4 into H1, then plus minus of L5 is G5 H1 S2. Okay, from this you can plus L1 into L3. Already you know the value of L1 and L3. So L1 into L3 can be written as G1 G2 G4 H1 S3. So after finding this, simplifying this, you will get delta. Okay, then substitute in transfer function, that is, you know the value of T1 also. T1 is G1 G2 G3 G4, plus you know the value of delta 1 is 1, plus T2 is G1 G5 into, again delta 2 is 1. Okay, you can put cross mark here, into whole divided by delta value is 1 plus G1 G2 into S3 plus G2 G3 into S2 plus G4 H1 minus G5 H1 S2 plus G1 G2 G4 H1 into S3. So this is the complete transfer function of that signal flow graph. Okay.